Hi everyone, welcome to our reality capture education series. Today's topic is time-saving tools for ground surface modeling. I'm Christine Grail with Leica Geosystems, part of Hexagon, and I will be your moderator for today's session. Our presenter today is Jason Dixon. Jason is a licensed professional surveyor in North and South Carolina who has more than 25 years of surveying experience and more than 15 years working with terrestrial, aerial, and mobile LiDAR data. From his time as an instrument operator and field technician to roles as a party chief, survey project manager, and LiDAR project manager, Jason has always been a passionate advocate for implementing the most efficient and effective technologies and workflows. Today, as reality capture consultant for Leica Geosystems, Jason guides surveying and mapping professionals on their journey to maximize productivity and success through innovation. Also on the line with us today, we have Seth Gulich, who will be answering questions behind the scenes. Please do ask questions at any time during today's presentation. If we can't get to all the questions in our live session, someone will reach out to you after the webinar by email. I do have a couple of quick polls to share before we get started in our session today. The first quick poll is, how would you describe your experience with laser scanning? Go ahead and take a moment to answer that question. Those of you who have been part of this series before have probably already answered this poll question multiple times, but we do just like to get a read on the experience level of those in our audience. And we have different people in every single session that we have. So it looks like most of those who are on the line with us today have experience, but would say that they're still learning. I would say that probably that does apply to most of us all the time. There's always a lot to learn, right? So I'm gonna go ahead and share those poll results just so that you can see where you're at in the overall scheme of things. And we do just have one more quick poll because the topic of today's webinar is Cyclone 3DR. Just want to find out whether those in the audience already have Cyclone 3DR or whether you're just exploring it as an option as you're working with all that fabulous point cloud data. So it looks like we're about an even split on that question. Maybe a little bit more are just exploring right now. I'm going to go ahead and close this poll and share those results so that you can see. And with that, I am going to turn it over to you, Jason. So you should see that on your screen just now.
Ah, perfect. Yes, there it is.
Take it away.
Which screen is it sharing? Do you see my, do you see 3DR?
I do see it.
Okay, perfect. It didn't give me a choice which screen I was sharing. I was making sure it was the right one. So, hey, thanks for that introduction, Christine. Like I said, my name is Jason Dixon. I'm with Leica Geosystems. Been scanning for roughly about 15 years, surveying for about 25. So I've got a lot of experience with scanning. Also doing a lot of topographic maps, 2D maps, stuff like that, specifically in Cyclone 3 or in Autodesk Civil 3D. So I know sometimes, and I remember doing a lot of this, especially in the early days, trying to get scan data into a workable format, extract the information you need, and get it to a inside of Civil 3D so you can start your mapping. It's definitely gotten better than what it was. Many years ago it was really rough, but there's a lot of tools out there now that helps. And one particular I'm going to focus on today is Cyclone 3DR, and show you some workflows that I've kind of developed just over the years. And of course, these tools have changed along with Cyclone 3DR. It's a great tool, great program. Lots of tools in here, and we're only going to be touching on just a very few of those. So Christine, you can see my screen moving around pretty well.
Yes, looks great.
All right. So this sample data set I have today, this is actually from a BLK to go. This is one of our handheld scanning products that we sell. It scans roughly about 420,000 points per second. Very quick, roughly a centimeter accuracy. But and And I specifically picked this data set. This was an area that I walked. It took me roughly about 3 to 4 minutes to walk it, several walks. But as you can see, there's a lot of noise in the area. There was a construction site that wasn't too far away, and it was a very dry, dusty day. So I specifically wanted to pick this data set because I wanted to kind of challenge it a little bit. And let's take a look at what you really would want to try to do, even when you do have a very noisy data set. Let me see, let me cut my layers on and off. So right now, this is obviously real world colors. Now, when I exported this from Register 360, the processing software, I went ahead and classified this, and I always recommend always try to classify, especially you can classify in Cyclone 3DR, you can classify coming out of Register 360, but classification is just really a fast, quick way to help you segment up your point clouds. And in this case, what we're looking for on this, and what I'm going to be focusing on today, is specifically creating a ground surface. So I don't want to get bogged down with everything else in here. I want to focus primarily on what I'm trying to accomplish. I want a ground surface, and I want it as quickly as possible. So one step, and this is the process I like to use, is we already have this classified. So now what I'm going to do is I'm going to extract. I'm going to explode by class. And I'll show you the reason why I do this. Now, if you can see over here on the side, now every piece is actually a separate piece. So now we can go through here and just cut off what we don't want. Now, of course, you would obviously want the ground class itself. However, I wouldn't ignore some of the others because there might be some pieces that maybe didn't get classed correctly, and you might want to just grab it just to make sure we have it. But as you see, I want to keep that one. There we go. I want to keep those. There we go. And that's pretty much the ground class. As you can see, just those three, let's say those three pieces. Now, they're basically being split up in three pieces, but I want to get them back together. So what you can do here on the left side is you can just right click, and we're going to group these back together. All right. So, and the other thing, just to point this out for any of you guys out there that use Cyclone 3DR, just remember over here on the right, you have full control of how it basically creates these folders. Like right now, that surface I just created is still in this folder with all of these other steps. What if I don't want it in that? So what we can do, you can create basically another root folder, which would be the top level, or a subfolder inside of this. In this case, I'm going to call basically another root folder. I've created a second folder down here, and that group that I just created, I'm going to actually cut that out and put it in its own folder. That way, I don't have to go back to this folder with all this other information in here. And maybe we want to save this. Maybe we don't want to delete this. Maybe we want to save it because we've got another piece of the project we'll be working on later. So, but that's always a key thing to remember. You can create folders and root folders and subfolders in here. So definitely use that to help you kind of keep things organized. It's just a useful little trick there. So from there, now there's several different ways that we can create meshes inside of Cyclone 3DR. And of course we have you can go straight from scan to a mesh. And you can do a lot of other useful tools as well. But one primarily that I'm going to focus on today is actually I'm going to do a DTM. And the reason why I'm choose to do this method to create our DTM is it's going to basically try to look at the bottom piece, even though we've already got a fairly clean data set to create ground. It's primarily going to focus on creating that mesh or that surface as one whole piece, holding the outside parameters as best as it possibly can. Like many tools inside of Cyclone 3DR, a lot of times, like for example, the grid size, this is taken by the software will take an initial look at the data set. And we'll kind of think of, okay, here's a good suggestion based on the density of the point cloud and the size of the data set to what we suggest you try. As far as extraction strategies go, fast is usually good just to kind of take a quick look at something. Primarily, I never use that. If you were trying to do a noisy point set, which for the most part, we've kind of got this cleared out a little bit, so it's definitely much better looking at. Local steep slopes would be really good for if you've got like a lot of curve changes or some like ditches, small hills or whatever, and you don't want to cut those out, but you want to make sure that it finds those. Definitely try those out. And one thing I'm going to focus on primarily today is doing a refined mesh method, which is basically going to take and it's going to do an initial take of the ground, and then it's going to look at it again and try to help refine it based on like the best grouping of the points. And the great thing about a lot of the tools in Cyclone 3DR is you have a preview button. So no matter what, I highly recommend doing previews because you might go through some of these settings a few times. Like for example, especially if you're in an area where you've got a very steep slope, you might crank this up to maybe 40%. Right now I've got it cranked up to around 26, 25. There's no really set rule of thumb on that. Just take a look at your data set. If you're trying to create a mesh on the side of a hill, you might want to increase that. So we've got the initial fit on the ground here. So, oh, and actually, you see we still got that piece right there. Actually show you. Let's say you really are just wanting to stay down here on the ground surface. So all I did was I'm going to go in here and you just see a piece. You don't have to redo all your classifications. Let's say, hey, you know what? I've got a piece right here. I really don't want this stuff up here. I just want to go to the very bottom ground surface. So what I'm going to do is I'm just do a quick clean and separate. I mean, there's other ways you can do this, but this is just going to be a kind of quick method just to say, hey, you know what? I want to stay down here on the ground today. So let's just take that piece and just going to delete that for now. So now, there we go. Now we're going to go back and do our DTM surface. So now, again, this is not the only way to create a mesh inside of Cyclone 3DR. For more experienced users out there, there's several different pieces, but like I said, today we're just going to focus on the DTM because that's what we want. We want a DTM. So hit that preview button again. And another thing while it's processing that I suggest to everyone, if you don't already do this, especially when you're working in Cyclone 3DR, keep a notebook. Always keep a notebook and keep notes. If you do a lot of this work, you're going to find that certain settings you're going to like better than others. You're going to find out, well, actually, if I'm looking for a ground that has curve, when I'm using a DTM, creating my DTM, certain settings like the grid size, where you're using local steep slope, refined, most of these settings, write those down. That way, each time that you're doing this, you're not starting over from scratch. Because depending on the type of data set you're collecting, whether it's RTC 360 data, BLK to go, even mobile LiDAR data, you're going to find certain settings work better on different surfaces. So it's always great to keep notes. So just a little side note there. So what we're going to do is I'm actually going to, I want you to take a quick look at this surface. Not bad, but as you can see, it's definitely blowing through the curb and gutter, which obviously if you've ever done topo work before, curb and gutter is pretty important. So, and this is why the preview button is so very important with Cyclone 3DR, any of these processes, is it allows you to take a few stabs at it, see what works best. So, take just a second longer. And again, our focus here is not to get a perfect clean point cloud. Our focus is we're trying to get our ground surface from scan data as quickly as possible and get it into our topo so we can start doing our mapping. So, and this process can vary a little bit depending on your computer, your memory. I definitely always recommend make sure you've got a good computer to do this. Definitely more than 64 gigs of RAM, good solid state hard drive, good processor. So, all right, we're getting a little bit better. Now I'll crank this down a little bit, but I'm going to say I'm going to go under 0.4 because I know a curb and gutter height can vary slightly. So we're going to try to get this down a little bit tighter. And you have options as well when you're creating this, and you see this down at the bottom, is you can then split that point cloud up again if you want, to where it's just the points on the ground, or the points not on the ground. You can do this all in one process on export, or you can just not worry about that and just go straight to the ground mesh. And this process and time could vary slightly, depending on, obviously how big the data set is. This section here is probably about roughly, I'd say about 400 by 100. So, all right, we're seeming to be getting a little bit tighter. So I'm actually, right now, I'm just gonna take this as it is because we could keep trying to play with this, but we know that we've got curb and gutter in here. We really want to get this detail out. So you could try to do another refined mesh. You could try to do some smoothing, but we know at some point we need that curb and gutter. So one process that I like to do is you just know that's going to happen. Why don't you just go ahead and do it? One way we like to do that is the virtual surveyor tool that is inside of Cyclone 3DR. This is one of the newer tools they added. If you're familiar with Cyclone Core, it's similar to that. It's not exactly the same, but it's definitely a means to get points out, and allows you to basically pick lines and you can create points as well. In this example right here, the settings, this is where you basically set up, like if you're familiar with the old core, is you set up your code. You can set up any kind of code you want. You can load these from another file if you like. You can save these out. I've already got these kind of set up. Basically back a curve, EP, face a curve, sidewalk. You can add to these whatever you want. So from here, I'm going to basically start a line. And right now, let's just say, for example, I want to do the EP, and I'm actually going to do this directly on, I prefer to do this on the point cloud itself, just because I feel like I can see more what I'm doing. And you definitely want it, whichever intensity you like to see, whether it's the real color, whether it's classification, whatever that is. Me, I like to do the inspection. I feel like the colors kind of pop out a little bit better. So again, back to virtual surveyor. We've already got our file preloaded, so we can now start extraction. We're going to focus on the EP for right now. And here's some tools. These are very common tools inside of Cyclone 3DR. You've also probably seen these in like CloudWorks and some other Leica softwares. You have different options here, how you can pick. For example, obviously, if you use the ground, that's going to try to take a best fit of the ground area, based on a search radius, which is this one's about 0.2 meters. Really good for picking ground. That way, if you're wanting to like get off trash and want to make sure you're getting to the ground surface, great for just throwing in spot shots. Obviously, there's other options here, but I'm primarily going to focus on the high and low. The reason I'm doing high and low is if you look in most curve, and of course we know that not every curve is perfect. Some of them's a little bit sloped, got a little bit more roll to it. It's kind of hard to get the high and low, but this is actually fairly good curve. It's relatively flat. So if we know we're trying to get, but actually the EP, which runs up to here, what we do is use low point, and if you put it right on the side of that curve, you notice how it keeps popping down to the bottom. Even if I'm up here, it's basically pushing down the bottom. So now EPs, I can start snapping. Now there's ways you can show the text with these points if you want to. Personally, I'm not doing that right now. And you can just keep going, just keep going. You see how quick and easy this is just to snap those in. Really allows you a lot of freedom in that. So now if you also want to do the front face the curve, it's also been called top of curve, whatever you like to call it. Exact same method, except now I'm going to use the high point. So obviously this does rely on having a decent clean point cloud. You can't have a lot of trash on this, and that's where classifying, you know, segmenting out your point cloud before you do this is really helpful. So now we can just do that front facing curve. You know, just try to find a good area to pick. Whatever, you know, whatever distance you want to pick it out. So now, there's your break lines. Of course, they're not perfect, but we can get them a little bit tighter. So let me show you one method I like to use. Once you do all these break lines, let's say, which I've already kind of done these anyway, just to kind of give you an example. These break lines have already been extracted, but one other method I like to use after using the virtual surveyor tool, and if you've gone through and picked pretty uniform like curves and stuff like that, you try to like maybe do, you know, at least 3-point curves. In surveying, you do 3-point curves or beginning and maybe 2 or 3 points in the middle and another point on the end. All those are going to be straight segments. So then you want that actually to be a little bit more uniform, of course. So at this time, you would take and go into cleaning. Under cleaning, go smooth polyline. And we're going to do like there's different options here. And again, you know, if you've got some different ones to pick from, just for time's sake, we're going to go with smooth because I've already kind of done some of this testing. The smoothing intensity, I've got it roughly set to roughly 10. You can crank this up really high. That's about half the smoothing intensity. And maximum smoothness deviation, this is basically telling it don't go too far away from where I picked. Don't get too out of hand. So, and if you had a really tight mesh, which, you know, we don't, we're trying to create the tight mesh. You could project these on the mesh, but in this case, we're not. So then you would smooth these out and it would create a smoother polyline. So, and just to kind of show you, this is what we've kind of already done. So now the reason why we created these lines is we are going to actually introduce these back into the mesh that we created. So we want it to tighten up. We want it to basically hold to that mesh as cleanly as possible. So from here, what we're going to do is, if you select the groups, of course, there's a whole bunch of points in here, but what you're really interested in is lines. And you could individually select them by holding control and then select the line, but also find that you can actually just select the folders and then the mesh. Here, we're going to go to surface modeling and we're going to sharpen the edges. And what we're trying to do is we're trying to basically introduce these break lines that we've created into our our tin. We're trying to create it to where they match what we're trying to extract. So what that does is that allows it to kind of tighten up a little bit some of these areas. So now you won't have the break line running in and out of the surface. It's saying, hey, make sure you match to this. So, and you could probably do this with several iterations. One iteration I like to do with this, and I'll show you basically the results of this. Cut my break lines off. You see it's still a little sharp here, so you can run through this process several times, and each time you do it, it gets a little bit tighter. So, okay, we put the break lines in, but now it's really looking kind of rough. So, all right, well, let's just maybe, let's do like a little global smoothing here, but we don't want it to pull off of what we just did. We don't pull it out of the break lines. So let's see if we can maybe tighten this up just a little bit. And you can do that. And then if you need to, if you see like it's pulled it too far away, or if it maybe created some variations of it, then you can actually sharpen the edges again. And all this is basically, it's like a method of almost, you're trying to just shrink wrap. You're getting a little bit closer, smoother, a little closer, smoother, but you're telling it the break lines are what I want you to try to hold to as best as possible. So on this case, I did this mesh and I did this process of the break lines, smoothing, sharpen edge again with the break lines, smoothing, and that got us down to a fairly good smooth mesh. Certainly not perfect, but definitely much, much better than what we had. So the great thing is now this is a lot of details and stuff that, you know, AutoCAD's probably not going to pick up on what you're trying to do again. What we're trying to do is we're trying to get this surface and these basically this break lines into AutoCAD. So once we're happy with our mesh and where it is, then we can take this mesh. There is a method where you can send things like basically right click and send things straight to CAD. If you do it that way, it's going to send this as a graphical like 10 surface entity into AutoCAD or Civil 3D. And everyone who has experience with Civil 3D knows that Civil 3D surfaces, they're not really a graphical entity. I mean, you could basically create the 10 surface and then try to reintroduce it into a surface. But I want to go directly from a surface directly into a surface in Civil 3D. So the best way to do that I'll find is basically export. Now I have that mesh selected. And what I'm actually going to do is an XML export. And so I've already done these a couple times. So I exported this out as a road XML. And also from here, now make sure your drawing, of course, is set to the right units. I use US survey feet. Insert and XML. Pick the XML you want. Parameters are good. Civil 3D always has something to tell us. And while that's thinking about it. And also the other process is, now we just take our break lines as well. I'll say we want to send these over as well. We want these in our drawing. So now, let's see if it's done yet. Oh, good old Civil 3D. There we go. I knew it could do it. So there's your surface. Actually, surface. Of course, I don't have the, let's change these over. Oops, wrong one. Let's get some nice 1 foot, 5 foot contours. So there's your surface. And it's ready to work with inside Civil 3D. You can cut this up a little bit. You start drafting right on top of it. Also, now, like our break lines, and I'm just going to send these directly. Hang on, do it this way. Send these directly to CAD. Now, I've had them highlighted. Hold select. I'm going to right click with Civil 3D open. If you don't have it open, it won't know where to send it. Send it. And there they are. Same thing with the next group. And there they are. So there you go. And this whole process roughly took me, I'd say roughly 30 minutes, depending on the size of the area that you're working in, the detail you're looking for. As you can see, now you're ready to start working inside of Civil 3D, start your mapping, your labeling. So that's just a really quick way to kind of get that in there. And there's other little things you can do. But for today, I'm really just trying to focus on the quickest method of getting you to this starting point so you can start your mapping. So, and that's my first example. Are there any questions before I jump into the next example?
You know what? I think you can go ahead and keep going, and we'll hold the questions till the end.
Okay, yeah, no problem. So so that data set was from a BLK to Go. Just want to show you that it can be done with two different data sets. And this data set was from an RTC 360. And one thing you probably already noticed from this is there's a lot more traffic. This was taken in downtown Knoxville, Tennessee, I think right around 4 o'clock. So probably right in the middle of rush hour here. So, and I think I did this in roughly about 15 setups, pretty quick collection. So now same process, I'm going to kind of run back through this. Of course, when I exported this from Register 360, I did classify it. You can also classify this in Cyclone 3DR. And again, this process will work with any data set that you bring into Cyclone 3DR. Obviously, we think, like this scanners are pretty awesome, but, there are other LiDAR sources out there. So if you can get it to an LAS, E57, for example, or some other file formats, you can get it into Cyclone 3DR. So if, let's say you do have a project where you have got some data from, like, say, aerial LiDAR, mobile LiDAR, handheld LiDAR data, terrestrial LiDAR data, and they're from different sources. You can still bring all those in and do the same process. So I'm going to run back through this same process again. Again, this data has already been classified. And I'm going to do this one just a tad bit quicker because I know I want to make sure we have time for questions at the end. So, of course, it's already been classified. The same process I did before is, and I've already got this done, but I'll just kind of walk through it again so you can see it. So I've already got this data set. I exploded it by classification. Now, if you, for some reason, don't have it classified, and this is another tool just to throw this out there, and you don't want to sit there and wait for it to classify. Hang on one second. You don't want it to wait for it to classify. You just want ground points. We do have the split ground points tool that you can use on this as well. But in this case, it's fairly quick to just go ahead and, sorry, I thought I had that off. One second. You don't want to have to wait for the split ground points. You can go ahead and just use the classifications, the same process I did before. You can grab the classifications, explode by class, group out what you want, and then group them back in together. And in this case, I did create a separate folder to show you this is still classified. See, there's our classified surface. So again, same process. I'm going to go DTM. I'm going to go, and this is relatively flat. Again, this is just a slide bar, as you can see. In relatively flat areas like this, I've found about 25, 26 works pretty well. Generally, the grid size here, it's usually trying to get a very large grid size. So I find that especially if you're trying to find the little, let's say, what you want to call it, undulations, variations in the curbing, basically the turn down walks, stuff like that, it's usually good to decrease this down. I go usually below 0.4. It's helped me find that curb. Again, use local steep slope because I know this is fairly clean already, but I know it's going to have some jumps here on the curb. I don't want to lose that. Refine. I'm not going to worry about splitting the ground, but I want my mesh based on my ground surface. And again, we're going to be using the exact same method we used last time. Once we create the ground surface, we know we're going to go ahead and just extract the line work. So we're going to use the virtual surveyor tool. And again, there's also the curb extraction tool script in here that's really good for like long runs of curb. You could just basic polyline and pick on the ground if you want. I'm using the virtual surveyor tool because I'm pretty comfortable with it. Whatever picking method you want, if it's a polyline, we can add it to basically to the surface to sharpen those edges. So whatever method that is that you like picking with. And again, this data set is an RTC 360, so it's a little bit more dense than the BLK to go. So it's probably, and I do have it cranked down. And the smaller you create this grid size, the more time it's going to take. And of course, anytime you do a refinement, it's trying to do a little bit more analysis on the surface, because it didn't actually show there's quite a bit of like cracks in here where this lane was added into this lane, and you can see some breaks in the pavement here, and it's really trying to find those. So we've got a fairly good start on the surface, and you see we've got a lot of driveways and walkways, so a lot of curb going up and down. We even got the sidewalk, and there's some current coming out of the driveway here. So again, what my goal here is I'm trying to get surface as quickly as possible. So I'm going to use the same method I did last time. I'm going to go extraction. I'm going to go virtual surveyor. And again, I have it set up, and you can set these up any way you want. If your company has standard, obviously description codes that you want to use, you can create these and load these up. and have them where it can be shared through any users in your office. So same process we did before. We're going to go through here, and we got EP. I'm going to just snap into this EP here. Same method I used last time. I'm going for lowest point right along the side of that curving here. This time I'll go around this curve so I can show you how the smoothing actually works. Okay, I'll stop there for now. Of course, you would keep going with this, all the way down. Same method as last time. Now I'm going to go high point on the side curve. And you notice how I do that. If I go up here and try to do that, it's going to try to snap up on top. I'm trying to make the tool work for me. High point, and I know if I stick it on this side, it's going to go snap right to the top of it. You see it's starting to turn down a little bit here as well. So for this example, just stop right there. And now, again, highlight the two break lines. I'm going to clean, edit, polyline edit. I'm going to smooth. Just go with the same settings we used last time. You see it's got different variations. Now you can really crank this up if you want, or you can crank it back down. It's just whatever you're really trying to do with this. Standard deviation, you could try to play with this number a little bit. I find this number works pretty well. So now, just adds a little bit of smoothness to it. It's just going to help it kind of find those, basically not make the curve look so broken up. So I went ahead and I did this extraction. Let me cut this on. 1 second. Here we go. There we are. Now this one I did have the textures on with the points. Obviously I'm not going to use them for this. Really I'm primarily looking at the line work. And you can see all this extraction I did. And this is roughly about the same area. You're about 350 feet, roughly just under 100 feet wide. And we take our mesh, same process we used last time. We select all our lines. We select our mesh, and we sharpen the edges. Clean distance roughly about 1/2 foot. I use that because sometimes we're kind of blue through the edges, especially right here. That's probably less than 1/2 foot, so I'm trying to get it pull up to that edge. I want it to move a little bit. And of course, you can kind of play around with this a little bit and try to see if you can find it, get a little bit tighter. Once it's done, you see it pulled to that edge pretty well right there. Instead of it being off, now it's right on it. So, and again, same process as before. I don't want to lose detail. So I want to try to smooth it to kind of get rid of some of these edges. So I keep my deviation down quite a bit. I don't want it to lose these points. I want to know where these holes and these cracks are. And same process as before. You can smooth this. And if you feel like it pulls it too far off your break lines, this allows it to kind of just makes a more uniform fit for the mesh. But you can see now it's kind of pulled away. You may be okay with that, maybe not. If you're not, obviously, whoops, here we go. Just grab those break lines again, snap it back into your mesh. And if you need to smooth it again, there's nothing wrong with smoothing it a couple times. If you're going back and forth with sharpening the edges, smoothing the mesh, sharpening the edges, it just kind of helps kind of get it a little bit more uniform and trying to hold to what you're basically telling the mesh that's important. You're telling it these break lines are important. So it's also obviously it's very important to pick good break lines as well. So in this process, I've already got this mesh done, and I got it fairly well fit onto these break lines. Same thing as last time. We're going to take this mesh and we're going to go export. It's selected. We're going to go XML. And of course, there are other options you can do here. I'm primarily going to focus on just the XML today. We would export this out, which I already have. You can see how fairly small size there. Bring this in the CAD. And actually, I'll bring it in the same. Well, actually, you know what? Let's do it this way. 1 second. Just use the same drawing file. There we go. Just for argument's sake, we're going to use the same file, just so I don't have to open up another blank drawing. Bring in the Tennessee roads, what I called that. Same as before. Take just a second. Of course, he's going to tell me something. And the same thing. Now we're going to go through here. We're going to select all our break lines, and same thing as before. And wait for it to kind of pop up here. Here we go. Now, same as before. Right click, make sure the drawing is open, and send to CAD. Of course, if you miss any, just go back in here. Okay, we've got more in here. Grab these, each one. Another reason why I don't like, if I'm not going to use the points, I wouldn't create them. That way I can just kind of sift through these and just, grab the lines themselves, each one. Here we go. Use these as many times as you like. It's not like an export, it's really directly interface and send it straight to AutoCAD. Very quick. All you need is just have AutoCAD open, have your drawing, obviously make sure units are set correctly. Definitely getting down to the bottom of the list here. Here we go. The only reason it's broken up so many folders is I did several different, I was messing around with some of the settings and several different iterations of it and stuff like that, but you can group these together a little bit tighter to just save time. Just want to get these into CAD. Here we go. We got them all. There we go. So now here's your surface. This is an actual AutoCAD surface, and of course you can change whatever presets you already have in. Actually, I don't have any of these, are just the standards. But that's it. That's pretty much the process. Same process, 2 different data sets. Again, I always highly recommend keeping notes anytime you're doing this, and write down which settings you're using, what kind of data set it was, what settings work best, and anytime you're experimenting with this, with a lot of the tools in Cyclone 3DR, use those settings initially to kind of start with. It's always a great starting point. That way you're not reinventing the wheel every time. But that's pretty much, that's road surface from Cyclone 3DR directly into Civil 3D. And both these processes roughly takes a little bit less than 30 minutes. Just depends on how fast you are picking break lines. So are there any questions?
There are, Jason. While you have the data set open, someone mentioned that a common challenge when creating a mesh for a surface is excessive triangles that adds to the surface size. And they wanted to know what the triangles look like in the sample surface.
So if you get if for some reason you don't want a lot of excessive triangles like that, you can see how I've got it's pulled pretty tight. You can do a reduction on this, and this would be another probably lesson, but there is a way to do a reduction, and you can set deviation control. But again, this goes to, you can get really carried away with this. This does allow you to basically do a reduction on this. Say you don't want all those little small triangles, because it's really not necessary. You can reduce that. But one thing you have to be careful of, and this is where you would really have to dial down your deviation control, is you don't want to lose your detail, like on, say, on your turn down, for example, right there. Actually, let me do smooth and wire. See, if you can just make sure you QC that. You can do that reduction. If your drawing can handle it, you can definitely You can definitely leave those little small triangles in there. I know sometimes it gets a little bit redundant and it gets overkill, and AutoCAD can get a little carried away with those triangles, and it doesn't like a lot of triangles. So there is a method to do reduction. Just highly recommend. Make sure you check your deviation control, and when you're done with that, definitely QC. Make sure you did not lose any detail on this as well. So you see right now we've kept it pretty good, maybe a little bit right here, but it's really actually did a pretty good job since I kept the deviation control down, snapping and holding to the brake line. So good question.
Jason, you collected the first data set with the BLK to go, and you collected this data set with the RTC 360. The BLK to go is like a handheld laser scanner. The RTC 360 has been around for, oh goodness, is it 5 years now? Okay, I was going to say 6, but 5 years. But it's kind of the workhorse of the industry, right? It's that standard at this point. And I think there is still some question among surveyors about whether the BLK to go could be considered a tool for surveyors. And so I'm curious what your experience was in that test data set. Is that something that you would recommend, going out and capturing the data for a ground surface model with the BLK to go, or is it a best practice to combine it with other scan data? What would you say?
Well, BLK to go is a very good tool. Obviously, you know, the noise on it's a little bit more than an RTC 360. RTC 360 data is very clean, basically less than 3 millimeters of noise, whereas in our BLK to go, I think you get about, oh goodness, about 5 millimeters of noise, but the accuracy is also, it's roughly a centimeter. So you definitely see a difference in the quality. Depending on what your parameters are for your project and what your accuracies are for your project, you can definitely use the BLK to go. But like any project for a surveyor, obviously our job, we are responsible to check and make sure that everything is accurate. So you would obviously set control. If you're worried about, is it tight enough, maybe take some check shots as well. It can definitely be used by surveyors to creating ground surface. It just depends on what type of detail you're looking for. It's a very quick, basic quick tool to allow you to collect an area. Say you're only limited to the amount of time and all you have time to do is walk it. It can be used for that. Obviously for the higher accuracy work, the stationary RTC 360 is a much faster method of collecting, and it's much more accurate. Well, I'm sorry, not faster. It's much more accurate. Obviously, BLK to go is faster depending on how fast you walk. I wouldn't recommend running with it, but definitely just a nice smooth walk, you know, with a BLK to go. And you can register data with BLK to go to control. So that would be definitely a way to help improve your accuracy.
That's very helpful. Thank you. And just one more point on that particular topic for those who are on the line and might be looking for, doing an evaluation, trying to figure out what their next scanner should be. There's so many scanners available on the market. How do you evaluate and make that differentiation between, you need a fast data collection, so you're looking at maybe a handheld scanner, but there are other ways to do that. Like what advice would you offer for someone who's in that situation trying to figure out what scanner to get?
Well, and my dad was a retired mechanic, so he always told me use the tool you need for the job. You know, don't try to use a screwdriver when you need a hammer, although that's pretty common. Don't use a pair of pliers when you need a screwdriver. What tool serves you the best? What tool are you gonna get the most use out of? Would you use it just for one specific project? Do you need to be okay to go just because you want to collect something fast? But what else would you use it? Is it going to match your project requirements for multiple jobs, or is it one specific job? Will an RTC 360 serve you better over a wider spectrum? As a licensed engineer, licensed surveyor, we're responsible for making that decision. We have to look at the tools and we have to decide which one's the best for us to get our job done, because at the end of the day, we sign and seal that project. We're responsible for the data and what's been done with it. If you want to know that it's accurate enough, you need to know, do you have means to check it? Are you doing check shots out there? Are you going to combine the BLK to go with an RTC so you can supplement certain areas to see if you're accurate enough? highly recommend that. Using a P-series scanner if you need to, you know, check any of your data, check shots, any of that, whatever it takes, because at the end of the day, we're the licensed professionals. We're responsible for what we put on that paper, because if we ever go to court or, you know, heaven forbid any of that, we're not going to say, well, it's the scanner, that's what it does. No, we make the decisions of what we use and what we do with it. So we're responsible for that.
Well, and I would think the same holds true if you're looking at even other makes and models of laser scanners. And that's why we have experts like Jason, like Seth, and you know, you guys are available to help guide that decision based on the expertise that you bring from your past experience in the field. Certainly you can help them make that decision. Going back to the ground surface models, we have someone who'd like to know what method you like to use for stitching multiple meshes together.
So stitching multiple meshes together, if I have some side by sides, and I'm trying to think if I know that, and it probably won't work if we had two surfaces, for example, they were side by side and they were broken off or whatever. You basically create bridges. Depending, and this probably go into a deeper discussion, there are some methods in here that where you can basically, oh, sorry, hit that button. You can join, it says join contours, and its definition of contour is the outside edge. You can fill holes. Let's say if you had holes in this mesh, for example, hang on. It won't be the exact same thing, but you'll get the idea. I'm gonna intentionally, oh, come back. Hang on. Where'd you go? Oh, I have too many separated. That's why. Hold on, let me cut these off. Let me show you this. So what we're gonna do is you have methods where you can basically fill a hole inside a mesh, and why it's not highlighting. So, you know, 1 second. Here we go. Sorry, I was overlooking the tool. I was looking for clean and separate, but I was looking for it over here. So for example, let's say, I can undo this. Say we had a hole in our mesh, you know, well, there's methods where you can basically, fill this in, like if it has borders around it, you can basically fill that hole in by clicking on this, fill that back in. I know it's not exactly the same because I just filled that in, but if you did have a mesh that had some holes in it, you could use that to try to fill it, especially if it's surrounded all the way around by the triangles. It'll try to fill that hole in, and you can do that based on like a deviation control. If it's on the outer edges, whatever, you may have to create like a bridge and then try to fill the hole in. There's several different meshing options in here, and that could be something, maybe that'd be something good to cover in another lunch and learn. But that would be the methods of which you could do that. You could try to bridge those together, then fill the holes in. If you've got meshes from multiple sources, hopefully that kind of answers your question.
That's awesome. Yeah, if you'd like more clarification for the person who asked that question, please go ahead and type that into the chat box. And for everyone who's on the call today, as you exit, there will be an opportunity to provide some input on what you'd like to see us cover in a future session. So please do take advantage of that. As Jason mentioned, we can certainly deep dive into some of these aspects in a future reality capture education series session. Here's a good question. I like the way this is worded because this person admits they're skeptical of the automation. And so they want to know, is there a quick way to cut cross sections to compare the mesh and break lines and the cloud?
Quick cross section care. So you're wanting to basically check and see if the point cloud is accurate to the mesh. So, and I know we only got so much time left. So if I was going to do cross sections, there is a way that you basically create a line, cross sections. You could do that along a tunnel. I would have to create the cross sections along this. And then you could try to create it on two different surfaces. That would be one method to check this. The method I would recommend to check it is actually your ground surface. Basically do a ground inspection. Now, let's see, this could be really rough. Let's see, I'm gonna do this live for you. Basically, I've taken my ground surface and my mesh, and I'm just gonna do a quick 3D comparison of this. And let's find, no, let's do regular steps. So now, and this is just a kind of quick way, and let's say we're looking for, say our tolerances. I know this isn't directly going to answer your question. You're asking a way that we can, how can you check to the point cloud to the mesh to make sure you did not, get too far off? Well, this would be a quick method to do that. Not in a cross section format, but basically in a 3D comparison format. Whoops, wrong button there. And basically let you know that everything's green. And hey, if you've got some areas that why is it off? This would be a fast way to kind of check it, and then you can go back and see, well, is there like some noise there? There were some scooters parked there, so it's telling me that it's a little bit of noise on that. Maybe we had some trash inside the curb here, but that would be a quick way to check your point cloud to your mesh, not in a cross section format. I know it can be done, it's just not quickly. I can't do it as quickly. There is a method to do it in here, but I know if I was going to check this and someone's going to ask me, well, how do I know that my mesh and all that smoothing and all that stuff I did, is it accurate to that point cloud data? Well, that would be a method to do it, because I've actually had a employer ask me that question before. Say, well, how do you know it's accurate? Well, now I can give them this report if I want to. And here you go. I can add this information in. And this is already inside of Cyclone 3DR. It allows you to basically show them, look, I've got this. That's how accurate it is. So does that hopefully kind of quick answer to your question? Maybe not in a cross section format, but it is a way to check it.
Thank you, Jason. Yes, if we need more clarification, please go ahead and enter that in the box. And I just appreciate how that question was worded, because I think all of us are skeptical of the increasing automation, especially you have artificial intelligence coming into play, and you have all these things developing so rapidly. And so I think, at the end of the day, everyone needs to make sure that their understanding of the basic processes are clear, right? They need to still understand the fundamentals. It all goes back to the fundamentals.
Absolutely, I agree. Hey, we're surveyors. We're going to ask the question. People are going to ask us the question. So you want to know that you got your bases covered. Put it nicely. So
we love that automation. We love the speed, but you got to make sure that you feel confident in the data at the end of the day. Here's one question. Are there cut plane tools similar to Core to view the point cloud against the surface?
Cut plane tools, like actually cut the planes. I haven't really done a lot of that in Cyclone 3D. I like to do the cut planes. There's the methods where you can do some cut planes through here. I know we could do some cut planes like slices and stuff like that in Register 360, but I haven't really done a whole lot of cut planes through here. A lot of times when I've checked things in Cyclone 3DR, to be honest, the method I just showed you, basically just taking the point cloud to the mesh and just do a quick 3D comparison, that's usually what I use to basically check. I'm not saying it's not capable. I think it could be done. That would be a good question. I'll probably ask some of my other guys on my team. They may have done that as well. But you can definitely send us that question. We can get you an answer for that. Or Seth might even be familiar with that process, or some of these other guys. But
yeah, I don't know if Seth wants to weigh in, but we have a recommendation from the audience to use the CloudWorks tab.
that too. There you go.
That's what I was going to tell you to do, Jason, was the CloudWorks tab has the slice planes.
Nice. Oh, there we go. So you can tell I haven't messed around with this that much. Most of the work I've done has been through basically, ground meshing, and I've done a lot of this and basically the breakline extraction. But see, there you go. Yeah, so you can do it through a CloudWorks tab.
One of the things I love about this team.
I appreciate that. I always like learning things new.
Exactly. One of the things I love about this team is that, between everyone that we have, There's enough expertise to answer just about any question that comes along. So, and
We have
our
a lot of tools.
audience, ask a peer.
There's so many tools in Cyclone 3DR, you know, just and I highly recommend all our users out there, you know, experiment with it. You know, you might find some different methods to do things, and there's more than one way to do things in Cyclone 3DR. That's one thing I love about Cyclone 3DR. So, you know, definitely get in here and experiment. You know, find some great new ways to do it. Show us some things. We'd love to see it. I love learning things as well. So.
That is fabulous. Well, Jason, thank you so much. That does bring us to the end of our session today. For those of you who are on the line, if you would like to try Cyclone 3DR for yourself, I know we had a bunch of people that mentioned that they're exploring it. So if you'd like to try it, there will be a link in the email that goes out tomorrow that you can download a free 15-day trial version and just give it a shot. And you can certainly reach out to Jason or Seth or anyone from our team if you have any questions about that. The next session in our reality capture education series is coming up on May 23rd, and we'll cover tips and tricks to level up your P-series scan data. And that is going to be presented by Seth. So please do mark your calendars and watch for registration details in the follow-up email that you should receive tomorrow. As you exit the webinar, please fill out the survey that should pop up on your screen. We appreciate your time and hope you found this webinar to be a valuable experience. Thank you so much, everyone.
All right, thanks everyone.